So if you Google installing the AWS encryption CLI, then we see how we can install it, and we have to use Python, and we can check the Python version. It gives you the instructions for Windows as well, and we'll use pip. So it's just pip install AWS encryption SDK CLI. So let me go ahead and run this command. And this is just for us to see how encryption works. This is definitely not needed for the exam to know how to execute this command. It's just for the people who are curious and want to see data key encryption in action. So now we have the AWS encryption CLI installed, and so if I do -- version, I get the encryption CLI to be 1.37, 1.3.7, and 1.1.5 for the CLI itself. Okay, so we're ready to use the encryption. Now, if we do examples, we can go straight to understanding how to encrypt a file. And so we'll have to export a CMK_ARN. So we have to figure out a key, and then we'll have to run the encrypt command, and then we'll have to run the decrypt command afterwards. So as far as the key we'll use the tutorial key from before, except this time we need the full ARN of our key. We cannot just use the alias. So I'll just say key equals, and I'll just paste this. Now my key has been exported, and now I'm able to run this command. So we first have to generate a hello text file. So I'll just say vi hello.text, and I'll say something super secret that's over 1 megabyte. So basically imagine this file is over 1 megabyte, and yeah, that'll be enough, okay? But this is just a text file, and it can be as big as you want. Here, it contains some very super secret data, okay? And what we want to do is encrypt this. So for this, we'll run this entire command right here, and you have the PowerShell equivalent if you need it right here. And so I'll copy it and paste it. And so here, the only thing I have to change, because I didn't name exactly just like them, I'll name this key. So key equals $key, and that should be it. So we're encrypting the data, and the input to the encryption is going to be hello.text. And the master key we're going to use is going to be this ARN coming straight out of Amazon. And we're going to output the metadata. If we want to explore the metadata, I'll probably just use a metadata folder right here. Encryption context is optional, and to be honest, I will remove it right now because we don't need to use it for now. And I will use the output, and the output is the encrypted file. Where will it go? Press enter, and it's a metadata output file cannot be in the output directory. So how about I make a directory called output, and I'll use the output directory to do this. Okay, so we're done. So now the file has been encrypted. So if we look at the results, we have hello text, that's our file that before encryption. We have metadata, which is the metadata that happened, and we have output, which is the output encrypted file. So let's look at the metadata first. The metadata contains a JSON document, and so I will just have it into JQ to print it a little bit clearer. So this JSON document has a header, and so it tells us the algorithm that was used to encrypt the data. It tells us what data key was used, the key provider, the encryption context. So all these things I described before are going to be in this metadata. This is just something you can use if you wanted to have a summary of what happened, but this metadata file is definitely not needed. So what I can do is remove this metadata file. And so the important thing is that if we go to the output directory, we get a hello.text.encrypted file. And so if I do cat output hello.text.encrypted, we see a lot of gibberish. It's because our file was being encrypted. The important thing though, as we can see, is that our file was being encrypted using this KMS key and that generated data key. So it allows the encryption SDK to decrypt that file in the future. So let's play with the decryption now. And for the decryption, we'll just need to run this one command right here. So let me just run it and adapt it because I did a few changes. So now we want to run decrypt function, and the input is going to be in the output directory of me, which is the hello.text.encrypted. The encryption context was not used, so I'll just remove this for simplicity's sake. The metadata output is, again, if we wanted to output the metadata, so I'll just have it right here. and the output is going to be a decrypted folder. Okay, so here we're decrypting the encrypted data, and let's press enter. We need to create the decrypted directory. Let's run this again, and now it worked. So now if we do ll, we see it created a decrypted directory. So if we look into that decrypted directory, we have the hello.text.encrypted.encrypted, so it's been decrypted in the end. Let's cat the content to make sure it was decrypted correctly, and we get back our super secret that was over 1 megabyte. So this is really interesting because using this encryption CLI, 2 commands, okay, I just had to get them right. Using the encrypt command and the decrypt command, we're able to encrypt a large file and decrypt a large file, and this involves KMS directly. So that's it for this hands-on. I hope you liked it, and I will see you in the next lecture.